Alright, in this video I'll be doing problems 5 and 6. Alright, so for 5 it says to find the values of x that make each expression below defined. Please remember that your denominator can never equal 0. So if you were to solve this as a one-step equation, we would see that x cannot equal 4. And the reason is if x was 4, then 4 minus 4 would give you 0, and then you would have 1 divided by 0, which is undefined, not possible. So basically you can set all these up the same way. They cannot equal 0. Now for this one here, it's a two-step equation. You'd have to add 6 first and then divide by 3. So x cannot equal 2. That should make sense because 3 times 2 would give us 6 and 6 minus 6 would give us 0. For C, you're going to have to factor out a GCF of x. Set each factor equal to 0, so x cannot equal 0, and 2x minus 5 cannot equal 0. So x cannot equal 0, or please understand that all you have to do is add 5 and divide by 2, so x cannot be 0 or 5 halves. For part D, this is a trinomial that factors as x minus 6, x minus 1. Those cannot equal 0, so if you were to set each one not equal to 0 and solved, you would get x cannot equal positive 6 nor positive 1. Okay? Then for 6a, remember you are going to multiply through by the LCD, so we can make this an easier problem, but we got to be able to correctly identify that LCD. So here your LCD would be 3x times the quantity 2x minus 5. If we understand that, then we say, okay, I'm going to multiply the entire equation by the factors in the LCD. Okay, so if I divide 2x minus 5 into 3x and 2x minus 5, the 2x minus 5 would cancel out, leaving 3x. If I divide 3x into it, it would leave 2x minus 5. And if I divide here 2x minus 5 into it, it would leave 3x. So at this point, we don't have to worry at all about the denominator. We simply need to multiply this out and make sure we don't make mistakes when solving. So 1 times 3x is 3x, plus, distribute your 4, 8x minus 20 equals negative 3x squared. Now this is a quadratic equation. So that means we always want to move our quadratic term to make it positive. So I'm going to add 3x squared over here. And because I have 3x and 8x, I'm going to add those together. So I'll come over here. 3x squared, 8x plus 3x is 11x, minus 20 is equal to 0. At this point here, you can try factoring. If factoring didn't work, then certainly quadratic formula or completing the square can work. But to factor this, I would use 3x and x and think what factors of 20 can I use that will combine to give me 11. So if you try, oh, and by the way, your signs need to be a plus and a minus. So I'll do that with a pencil just in case we end up changing it. So I'm just going to go through this thinking process like I've taught you how to do trial and error. So if I try 6 and 2, if I put a 6 here and a 2 here, that will give me a 6 and a negative 6. That will not give me an 11. If I switch them around and put the 6 and 2, then that would be negative 18 plus 2, which would be negative 16. That's not what we're going for. So now let's try some other factors. Maybe 4 and 5 will work. If I put a 4 here and a 5 here, that gives me negative 15 plus 4, which would give me negative 11. So it looks like I should have the numbers right. I just need to switch the signs. If I make this subtract and that positive, then I've got 15x minus 4x is positive 11x, and that would be correct. So now that I feel good about it, I'll do it in pen. These are my two factors. To solve them, you set each factor equal to 0. I'm hoping you can do that in your head. And we get at that x is equal to positive 4/3 and negative 5. Now, in the instructions, it says be sure to check for extraneous solutions. So extraneous solutions are the ones that come from the restricted value. So think, what can x not equal? Well, in this equation, if I've got a denominator of 2x minus 5, then x cannot equal positive 5 halves. If I have a denominator of 3x, so that it doesn't equal 0, I can't let x equal 0. So as long as our answers are not the same as our excluded value, then we can conclude that these would be the correct values. So 4/3 and -5. For part B, you have to think of the least common denominators, the smallest number that all three of these terms will divide. 15, 5, and 25, 5, and 15, if you were to list out multiples, it would come out to be 75. And just for those that struggle with that, 5, 10, 15, I did this in class today. And then for 15, your multiples are 15, 30, 45, 60, 75, 90. And then for 25, we have 25, 50, 75, 100, 125, etc. So it looks like at 75, we'll finally get there. And if I were to keep going, oh, sorry, I didn't realize you couldn't see that. We would see 75 work. So 75, and of course we need x. So that's our common denominator. So what do we need to multiply this by to get 75x? A 3. Sorry, raise that up a little bit. We need to get 75x, we would take 25x and multiply by 3. So that means I need to distribute 3 over this quantity. To get 75x, I would need to multiply 15 by 5. 15 times 5 is 75. So I have to multiply the 8x by 15 also. And then to get how many times is 15 going to 75? That would be 1, 2, 3, 4, 5. So I've got to multiply this by 5, so I need to distribute 5 up here. Now, remember, at this point, when solving, all these have like denominators, so I don't need to use that anymore. So I'm going to distribute what I have up here, and we would get 3x plus 9 equals 15 times 8 is 120. So we get 120x plus 5x minus 30. I can simplify on this side, so 125x minus 30. I normally do a shortcut, but I'm going to be very deliberate with my steps here, so there's no question about where anything comes from. Oops, I'm sorry, that should be minus. And then I need to add 30 to both sides. So we get 39 equals 122x. Divide both sides by 122. And that's our answer. X is 39 over 122. We could certainly store that as x and check that as well. 2 left. All right, for part C, what I need you to recognize on C is that for these fractions, there's no adding or subtracting on either side in terms of adding rational expressions together. We have a rational expression equal to another rational expression. However, these have like denominators. So if these two fractions are equal, then that means that this numerator is equal to this numerator. So that means I can ignore the common denominator here and just set the numerators equal to one another. It is another quadratic, so we want to set that equal to 0. And let me see, 41, I think that was negative 60. Yeah, negative 70, my bad. So if I subtract 11 from both sides, I get negative 70 equals 0. So this should be a simple one to factor because a is equal to 1. I can use 7 and 10 to get 3. So if I do x plus 10 and x minus 7, then I get the values of negative 10 and positive 7. But remember, again, to check it against extraneous values. If you look up here, x cannot equal 7. So if we get 7 as a solution, we have to throw that out and our only solution will be x equals 10. All right, next for part D, this is over 4, or 4 is over an understood 1. If we put that a whole number over 1, it helps us to see this as a proportion, to recognize that you do need to multiply this denominator here by 4. So I'm going to keep the numerator here on my left, but then set that equal to what we get when we distribute 4. So we get 4d squared plus 16d minus 20. At this point, I'm going to subtract my terms over here so I can keep a positive coefficient. And so I get 0 equals 2d squared plus 13d minus 15. I'm going to factor this quadratic. And I need to think, where am I going to put my signs to end up with a 13? If I put, they've got to be opposite signs too. So I could try a positive here and a negative, and try 5 and 3. But if we do that, that's negative 6 plus 5. I'm sorry, slide this up. That would give us negative 6 plus 5, which would be negative 1. That would not work. If we do 3 and 5, and certainly some of y'all will probably see this quick too, like I do. But negative 10 plus 3 gives you negative 7, so that doesn't work. So if we've exhausted those factors, then we try 15 and 1, okay? So 3 and 5, 15 and 1 are your possibilities. If we put a 15 here and a 1 here, it will work, because now we have 15d minus 2d. 15d minus 2d gives us 13d. So now that these are correct, oh my gosh, stop ringing. I can solve and say that d equals negative 15 over 2 and positive 1. However, we need to think back to extraneous values. If I factor this denominator, which is what we always look at to determine extraneous values, we would get, let's see, a positive 5 minus 1. So that means that d cannot equal negative 5 or 1 for this problem. Well, if you look, that means that 1 is excluded, so we can't keep that as an answer. We have to throw that out and only keep negative 15 halves. All right, good luck on your test, guys.